Okay everyone, so what we're going to be doing in this lecture video is talking about how to calculate acceleration. So we spent a lot of time graphing and trying to depict what motion looks like. In this video, what we're going to be shifting to is kind of how can we model it beyond just graphing? How can we model it using some kind of computation or some kind of math to help support what we're doing? Okay, so let's begin just by redefining what acceleration is. So we know that acceleration is where we have a change in velocity over time. Okay, and we know how to depict that, right? We've talked about what it means to change a distance over time, and this where we're talking about just changing our velocity. Okay, so when we depict this, right, acceleration, we define that as the letter A is going to be equal to or equivalent to some kind of change in velocity over some kind of period or change in time. Okay, so remember when we're talking about this delta or this triangle, okay, the delta is just equivalent to change. Okay, and in science, when we're talking about a change like this computationally, the change is going to be equal to whatever we end with, our final value, minus whatever we start with, our initial value. Okay, all right, so in this case, when we're talking about change in velocity, we're talking about our v final, so wherever we end, minus our initial. And all of that will be over what our change in time is. So whatever our final time minus our initial time. Okay, so again, it's just following that pattern, right? Looking for whatever our final is minus our initial. Okay, so let's show kind of how these equations work, and let's do that by just starting through trying to answer one of these questions. Okay, so the question that we're going to start with is this one where Timmy changes velocity from 40 meters per second to 60 meters per second, and he does that in 20 seconds. The question's asking us to find his acceleration. Okay, so let's just list what we know, right? So like all of our questions that we did for speed, we're doing the same thing here where we're trying to write down what do we know? What are the variables that we know? Okay, so in our equation, the variables that we have are acceleration, we have our final velocity, our initial velocity, our time, so whatever our change in time is or however long it takes us to do that. Okay, so those four things. So we know that from the question that the acceleration is what it's asking us to find, right? It's asking us to find his acceleration. We know that in the question it's telling us that he changes velocity from 40 meters per second to 60 meters per second. Okay, so that means that he went from 40 meters per second initially and ended at 60 meters per second. Okay, so that is the values in which he changed. Okay, and we know that he did this in 20 seconds of time. Okay, great. So we have all of our variables here. So now we need to come up with an equation that helps us answer this, right, or solve for A. Okay, so we know from our basic acceleration equation that acceleration is equal to our final velocity minus our initial velocity all over our change in time. Okay, great. So we have our equation here. All right, let's start doing the calculations. Okay, so we know that our acceleration is going to be our final velocity. In this case, it's 60 meters per second minus our initial velocity, 40 meters per second, and all of that divided by the time it takes us to travel, which is 20 seconds. Okay, so if we simplify this, we know that we have 60 minus 40. Okay, so that value is going to be 20 meters per second. And we do that in 20 seconds. Okay, so if we simplify that equation, right, that's telling us basically that our acceleration is going to be 20 divided by 20, which is 1 over 1, right? Those are equivalent. Meters per second divided by seconds. Okay, so what that's telling us here is that our change in speed, right, is 1 meter per second, right? So we're increasing that velocity, and we do that every second. Okay, so in this case, we do not cancel out our units, right? Because what we have here is meters over seconds, right? So these are not in the same or in different locations, right? They're not going to be cross multiply and you can get rid of them, right? In this case, we both have seconds in the denominators of these fractions, okay? So essentially what that's going to mean is that it's meters over seconds times seconds, right? Since these are in the denominator together. So our value then would be 1 meter per second times second, or 1 meter per second squared. Okay, so acceleration is always going to have some kind of squared value for time, right? That's just because we're doing some change in a period of time, right? So there's a rate in which we're changing the time. Okay, so just note that if you get acceleration, you're going to have a value that's going to be like that. That's going to be squared. Okay, all right, so that would be our final answer, 1 meter per second squared. Okay, so 1 meter per second squared. Okay. All right, so that's a basic calculation using acceleration. Let's try going through and talking about what's happening with kind of a different scenario, right? If we're asked to follow or solve for a different part of the equation. Okay, so let's start here for this one. So in this one, Jenny's traveling at a velocity of 100 meters per second. She accelerated to that velocity at 7 meters per second, okay? Which, remember, meters per second is the same as meters per second squared, okay? They're equivalent, okay? All right, so what's her initial value for velocity if she did this in 5 seconds? So let's go through what we know in the question. So we know Jenny is traveling at a velocity of 100 meters per second. Okay, so we know that our variable for that is going to be 100 meters per second, and we know that our velocity here is our final velocity, right? Because she's traveling at that point at that time, okay? All right, we know they accelerated to this velocity at 7 meters per second. So that's actually our acceleration. We should know our acceleration is 7 meters per second squared, okay? All right, so this is asking us to find her initial velocity, right? Given that she did all of this in a time of 5 seconds. Okay, so let's figure that out. All right, let's use this our equation for acceleration. So we know our acceleration is VF minus VI all over t. Okay, so what we need to do is manipulate our equation so that we've got initial velocity by itself so we can solve for that value. Okay, so let's just move our variables around. Okay, so we have a VF minus VI over t. So the first thing that we need to do is get rid of t, right? So we can get VF minus VI alone. Okay, so what we can do is if we take t and multiply it by either side, we know that a times t is going to be equal to VF minus VI. Okay, our t's cancel out since we multiplied both sides by that. Okay, so we've got all our variables, right? It's still there, just the relationship's different. Okay, now we need to get VF by itself. So right now we have VF minus VI. Okay, so what we can do is if we subtract VF from both sides, right, we've got AT minus VF is equal to negative VI. Okay, so if we multiply everything by -1, just to get rid of this to make VF the same, or positive, right, we know that our initial velocity is going to be equal to VF minus A times T. Okay. All right, so let's go ahead and solve for that. Okay. So in this, we're going to start by just writing out what we know. So we know our equation is VI is equal to VF minus A times T. Okay. So VI will be equal to our final velocity, 100 meters per second squared, or sorry, 100 meters per second minus 7 meters per second squared times time, which is 5 seconds. Okay. So in this, right, we have meters per second squared, so second squared in the denominator, and this seconds in the numerator, so we actually can cancel out one of our seconds. So our value here is that we're subtracting 7 times 5, which is 35 meters per second from 100 meters per second. Okay, so then what that lets us do is actually subtract, right? Now we can subtract those values since they have the same units. So what we're going to get is 100 minus 35, which is 65 meters per second. So our individual is traveling 65 meters per second and then accelerated to 100 meters per second during that time. Okay, so our final value that we should get would be 65 meters per second. Okay, right, so I know that I did it right, because my units here actually match velocity, okay? Right, everything worked out, my units worked out great, so that chances are I probably did my question and set up correctly, okay? All right, so those are some examples of how you can go about calculating acceleration. So we're going to practice that some more and do more examples of where we're having these calculations just to practice. Okay, all right, and we'll need these calculations to kind of help us as we start moving into some slightly more complicated equations, right, that deal with this motion. So we're going to put together everything we learned about speed with everything we've learned about acceleration and kind of put them into a way so where we can figure out not only just velocity or acceleration, but also potentially how much displacement has occurred in our movement. Okay, all right, so that's kind of the next step where we're going to go in kinematics. So if you've got more questions, let me know.